Let's get started. So the goal of our project was to predict a 1 to 5 star rating for Kindle books based on written reviews by readers. So our objective for this project was to develop a model that was able to achieve at least an 80% validation accuracy on predictions. So for some motivations behind our project, some could include that authors and publishers might be able to take these reviews and see how their books fare before actually releasing them, as well as the fact that the neural network could be analyzed to pick up actual word sentiments to see how different reviews could be interpreted based on certain keywords. And for the purpose of this project, we only focused on book reviews. However, reviews could be made for any sorts of products, such as electronics or anything you could find on Amazon. So for our data and pre-processing, we used a data set containing review texts and their given ratings from a scale of 1 to 5. The genres of the books were also retrieved using Amazon's item lookup API. And so if you want to actually find the data set, you can go to these links. For the data processing, the reviews were tokenized and normalized using the Spatie and Torch text libraries. And then the length of the reviews were also kept to a maximum character length of 2,000. And then genres were encoded using pandas. So an important detail for our data set is that although the reviews were from a scale of 1 to 5, there were very few 2 to 3 star ratings. Therefore, it's very difficult to create new features for these. So the most feasible course of action for us was to simply label 1 and 2 stars as label 0 and 4 and 5 stars as label 1, which could be construed as a negative or a positive label.
Okay, so moving on to the actual models themselves, we have 3 models. The first one is the baseline model. Now, this baseline model is very basically takes the tokenized word indices, embeds them into their unique word vectors, and averages them before putting them through a fully connected layer. However, what is special about our baseline model is that we also tokenized and embedded the book's specific genre as well, and then that is concatenated with the average word vector before sending it through the model to take consideration of different sentiments with different genres.
And so for the RNN, we just used a batch size of 128 with a learning rate of 0.01. And the RNN used was a GRU model to create the hidden states.
Our last model, the CNN model, has 2 different paths of convolutions, each with a default of 50 kernels, because that's what went well with assignment 5. And each of them had a default of 2 to 4 as their respective filter sizes. Now, what is different about our model is that we added a dropout layer after each ReLU activation function after the convolutions have been taken to avoid overfitting, as that was commonly a case. A batch size of 64 was used. And moving on to the diagram of our baseline model, as you can see, the word vectors are like average and then concatenated with the genre one hot encoded vector.
Yeah, and this is also a diagram of our RNN. So we had the GRU model as well as the embedded genres. You want to just keep going? Okay, because we're running out.
Oh. And so as you can see, there are 2 different channels, and we added a dropout layer, and then we max split it and concatenated it.
Okay, so for our quantitative results, our baseline accuracy was around 74% for our testing set, 85% for our RNN, and our CNN managed to reach around 81%.
So as you can see, our model definitely learned it from an accuracy of 0.668 or 68% to an accuracy of around,
Okay, yeah, so these are just the graphs of our accuracy plots.
Qualitative results. Sorry about that. So as you can see, so what we noticed was that The 1 to 2 star reviews and the 4 to 5 star reviews had very similar validation and testing accuracy for like all 3 models. However, in almost all cases, if not all of them, the outcomes for the 1 to 2 star reviews always do 1 to 2% better than the 4 to 5 star reviews, and we suspect that this is the case because after analyzing our data, we actually realized that there actually might be because there are more ways to express that you are satisfied with something, and then there are ways to express dissatisfaction, and we actually saw this.
Okay, and so for our reflection, we managed to reach our objective of around 80%, which is better than human capabilities and is better than a random guess of 50%.
Well, that was a good choice to convert your labels to binary, actually. Often
yeah,
that's a sensible thing to do. And I've done it in some research in this. It's always a good way to start, to go for something similar like that. And Andy, I liked your explanation of why the negative result, the lower result is harder to pick up in the text. I think that makes sense, actually. Yeah, so the only comments I have, Mike?
So yeah, for making it binary is good, but it is forcing a 3-star review to be pushed to either become negative or positive, despite it probably being a neutral. So you might have seen, it would have been at least interesting to see what would happen with 3 labels, just so you can maintain that neutrality.
We actually did do that. We actually began one hot encoding with all 5 labels, and then we got really poor results because of what, as we mentioned, there were very few 3-stars. And then we also did a one-hot encoding with a positive, negative, and neutral, which was -1, 0, and 1. And that was also not great because, as mentioned before, the 3 stars are actually very rare. And I think that is expected because most people do give 4 and 5, and if you didn't like it, you just end up giving it a 1-star anyways.
Yeah, so fair enough.
Great, we're going to move on. Thank you very much.